Okay, let's see an example of implicit differentiation. Here when we have ddx for x to the fourth, and the variables agree, when those two variables agree, we find the derivative of x to the fourth for x to the third. So that's the answer. ddx of this one is 4x to the third. But when the variables disagree, we need to use the chain rule, because we find the derivative of this one, 4y to the third, times dy dx. Okay, the derivative of y to the fourth, okay, and then the derivative of y. The derivative of y is dy dx. Okay, let's see an example. Suppose we have here x squared plus y raised to 1/2 equals 4, and we want to find ddx. That means the derivative respect to x. Of course, the implicit differentiation, you already have to be clear on limits, on derivative, basic differentiation rules, and all those previous topics. So ddx of this one is 2x plus, in this case the variables agree, so we find the derivative is just 2x. But in this case the variables disagree, so we use the chain rule. That would be the derivative of this one, 1/2 of y raised to -1/2 times dy dx. Okay, because it's the derivative of this one times the derivative of the y, which is dy dx, equals 0, because the derivative of a constant is 0. Then we find dy dx. Dy dx, it's equal. This one is positive, move here negative 2x divided by all this, 1/2 of y to -1/2. We can keep working with this. 1/2, 2 divided by 1/2 is 4, or it's dividing, you multiply by the reciprocal, that will be -4. -4, the x keeps in the same place, and y is raised to -1/2, so we can move this up and change the sign of the exponent. We can put y to 1/2 or a square root of y, which is the same. Let's try the square root of y. Okay, and that will be the answer for dy dx. So dy dx, it's equal -4x square root of y. Okay, that is this one. Now let's check another example. When we have here x squared times y, the same, we're gonna find ddx. When you have a product, we need to use the product rule. Previous topics for this is the product rule, the quotient rule, the chain rule, and basic differentiation rules. Okay, ddx, we find the first one, x squared, times the derivative of the second one. The derivative of y is dy dx, because the variables disagree, plus the second one times the derivative of the first, 2x. Okay, that will be for this one, plus we repeat the same process, because this is a product, we use the product rule. The first one, again, x squared, times the derivative of the second one, 3y squared dy dx. Okay, plus the second one, y cubed, times the derivative of the first one, 2x, equals 0, because the derivative of a constant, it's equal 0. Now let's put all dy dx in one side, in the left, and the other expressions to the right. It's like maybe you listen in algebra 1, variables to the left, numbers to the right. We're gonna do the same here. Dy dx to the left and expressions to the right. So let's write x squared dy dx plus x squared 3y squared dy dx equals negative, let's rewrite this one in 2xy, because they are multiplying, doesn't matter, and here the same, it's minus 2x y to the third. Okay, now we factor dy dx, and here is x squared plus x squared 3y squared equals, we can put the negative if we want it. Let's factor the negative. We can factor even negative 2xy, but just let's factor the negative 2xy plus 2xy to the third. Okay, like this. And the final answer would be dy dx would be equal to all this divided by this. So let's write negative 2xy plus 2xy to the third divided by x squared plus x squared 3y squared. Okay, now we can factor x here, we can factor x here, and then we can cancel. We can do many things, but just the process of the implicit differentiation is this one. Then the next part here is algebra, pre-algebra that you know how to do it. But this is just the process of the implicit differentiation. I hope this video helped you, and we're gonna make more videos, even some word problems using derivative. Thank you so much.